Hi all. Let's see the next topic of fourth unit, which is cache memory. Coming to the contents, today we are going to discuss about an introduction to what is a cache memory and what are the basic principles of a cache operation and how do you measure the performance of a cache memory. Coming to the introduction, as we know that there are different types of memories that exist in your computer system. One of the type is a primary memory, which is your RAM, which is a combination of both RAM and ROM, and you also have your secondary memory such as your hard disks or ssds. But there is also a other type of a memory which is also existing in your computer, which is called as your cache memory. So what do you mean by a cache memory? So cache memory is nothing but it is a volatile, small and very high speed semiconductor memory. So by nature it is volatile in nature, similar to your main memory, and which is a small memory, small in size compared to your main memory, and very high speed memory. When you compare it with your main memory, it is a very high speed memory which can speed up and synchronize with the high speed CPU. So this, why do we need to have a cache memory when we already have a primary memory present in your computer? So the reason is the speed of your CPU is very high, which is it is a high speed CPU. And the main memory, in terms of accessing the information from the main memory is far away from the CPU, which requires some amount of access time. So which is going to increase the execution time of your CPU, right? So whereas if you look at your cache memory, it is placed between the CPU and the main memory so that most frequently accessed information by the CPU is placed into your cache. And compared to your size of your cache memory, the size of the cache memory is very less compared to the size of your main memory. So you cannot place all the data which is present in your main memory into your cache. So in order to speed up the execution of a CPU, only the most frequently accessed information is placed into your cache memory. And the reason why we are placing only the most frequently accessed instructions is in order to reduce the average access time, so that you can increase the execution time. You can speed up the execution of your programs. So a cache memory, it acts as a buffer between the CPU and the main memory, and it is used to reduce the average access time to access the data from the main memory. And the data or the contents of the main memory that are frequently accessed by the CPU are stored in your cache memory. And the reason is because so that the CPU or the processor can easily access the data in a less amount of time. So whenever a CPU needs to access a memory, it first checks the cache memory. Before searching into the main memory, it will first check the cache. If the data is found in the cache memory, then the CPU will access that particular data and executes it. But if the data is not found in the cache memory, in that case, the CPU will move to the main memory so that it will access the data from the main memory. So in terms of cache memory, it gives you a faster access time because it is positioned between the CPU and the main memory so that the CPU can quickly retrieve the data from the cache memory rather than from the main memory. So it is a faster access. Next is reduced latency. Reduced latency means that when you are storing most frequently accessed data in the cache memory, it minimizes the time it takes for the CPU to fetch the instructions and the data from the main memory. So it reduces the latency time. So next, coming to the basic principles of a cache operation. So if you look at the example of a cache memory, this is your main memory and this is your CPU. So this cache memory is placed between the main memory and the CPU so that it would be easy for the CPU to access a cache memory faster compared to accessing the main memory. And not for all the data and instructions, only for the most frequently accessed data and instructions are placed into the cache so that it would be easy for the CPU to access the particular data and instruction in a shorter time. So the main memory, if you see the capacity of a main memory, it is capable of storing 32K words where each word is of size 12 bits each. And Out of this 32K words of your main memory, only 512 words can be placed into your cache memory. So that is the reason we say the cache memory is very less in size compared to the size of your main memory. If you have a 32K words present in your main memory, the cache memory is only capable of storing 512 words out of 32K words. So for each and every word which is stored in your cache, there will always be a duplicate copy which is present in your main memory. And the CPU can communicate with both the main memory and the cache memory. And the core operation of your cache memory revolves around predicting and storing the data that the CPU is likely to need soon. So you cannot store all amount of information or data into your cache, whatever is there in your main memory. You have to predict which type of information and data is most frequently needed by the CPU, and those type of data only has to be stored in your cache memory. Let's see the basic operation of a cache memory. So whenever a CPU or a processor needs to perform a read or a write operation in the main memory, first it checks for the corresponding word in the cache, whether it is present in the cache or not. So it how does this check is, it will first send a 15-bit address of that particular word to the cache, so that the cache will be examined. The cache will first check that particular address, whether it is placed in that particular word is present in the cache memory or not. If the word is found in the cache, we call it as a cache hit. So in case of a cache hit situation, the particular word is read from the cache memory. If the word which is addressed by the CPU is not available in the cache at that point of time, we call it as a cache miss situation. So whenever there is a cache miss situation, the main memory will be accessed to read the word. It is not present in the cache, but obviously that particular information will be available in your main memory. So the CPU will access the main memory in order to read the particular word from the main memory. So whenever a read request is received to the main memory from the CPU, what the main memory will do is the contents of that particular block of word. So as we know, the block contains a set of words. So whichever word is requested by the CPU, that particular block, whichever block contains that particular word, that will be transferred into the cache. So for a cache miss, whenever there is a cache miss, so the cache memory will allocate a new entry and copies that particular data which is requested by the CPU from the main memory into the cache memory, and then that will be given to the CPU for execution. So consider a situation in which the cache is full. There is a cache miss, the CPU has requested for some word, but at that point of time that particular word is not available in the cache, so it has to be bought from the main memory and kept it into the cache, so that the CPU will access that particular word. But the cache is full, there is no space available in the cache because it is at a limit, it is the size of the cache is very less. So in that case, whenever a cache is full and the memory word is not in the cache, then it is the responsibility of the hardware to decide which block that is already existing in the cache has to be removed in order to create a space for the new block which is referred by the CPU. So there are certain collection of rules for making this decision. We call them as the replacement algorithms. You might have already heard about these replacement algorithms in your operating system with respect to a paging concept. So there are different types of replacement algorithms like least recently used, first in first out page replacement, and least frequently used page replacement. Whenever we have to replace a block in the cache with the new block, then you have to, in case of LRU algorithm, you have to replace a block that has not been accessed for a longest period of time by the CPU. So whichever block that is present in the CPU is not, so whichever block that is present in the cache is not being accessed most frequently for a longest period of time by the CPU, that block will be replaced with the newly requested block. So in case of a first in first out, whenever it replaces the oldest block in the cache, regardless of how frequently it is used, no matter it might be used in the recent time. Even though if that is a block which has entered into the cache first, that will be replaced with a newly requested block. In case of least frequently used algorithm, it replaces the block that has been accessed the least often. Whichever block which is not being accessed more often, which is least often accessed, that block will be replaced with the newly requested block. So next is the measuring the cache performance. So how can you measure the performance of a cache, whether it is good or bad? So that is measured in terms of a ratio. We call it as a hit ratio. So the performance of a cache memory is frequently measured in terms of a quantity called hit ratio. So what do you mean by a hit ratio? It is nothing but when the CPU refers to cache memory and finds the particular word that it is requesting is present in the cache, then we call it as a hit, or we can also call it as a cache hit. And if the CPU is requesting for a word in the cache, and if that particular word is not available at that point of time in the cache memory, then obviously what it has to do, it will be in the main memory, so it has to go and access the main memory. So in that situation is said to be called as a cache miss situation, or it is simply a miss. So in case of a miss, the CPU must read that particular block from the main memory and place it into the cache memory. So cache hit is nothing but if the requested word is found in the cache, it is directly read from the cache memory by the CPU. We call it as a cache hit. And if the requested word is not found in the cache, the main memory is accessed to retrieve the word by the CPU, and we call it as a cache miss. So we based on the cache hit and cache miss, we have a ratio called hit ratio. So hit ratio is nothing but the number of hits divided by total accesses. Say for example, the CPU has accessed that particular word 10 times. Out of 10 times, it is present in the cache, the hits are only 2. So the ratio is 2 by 10. So the performance of a cache is 0.2. So say for example, out of 10, 9 times but it is the number of hits is 9. In that case 9 by 10. So zero point 0.9. So the hit ratio, that is called as a hit ratio. We calculate the miss ratio. Miss ratio is nothing but number of misses divided by total number of accesses for that particular word. So a higher hit ratio indicates the cache is performing better. The performance of a cache is good, and as it means that the CPU is spending less time waiting for the data. So whatever data or whatever word that is being requested by the CPU, it is always present in the cache at the time expected. So the goal of any cache system is to maximize the hit ratio. If hit ratio should be very high so that CPU need not has to wait to go and access the main memory and get that particular word from the main memory and place it into cache and then access it. So that is how we measure the performance of your cache memory. Next, we'll see the advantages and disadvantages of a cache memory. So in when we'll compare it with in terms of a main memory. So coming to the advantages of cache, it is faster in terms of access than main memory, and reduced access time since it is very closely placed with respect to a CPU compared to your main memory. The access time is very less in order to access any type of information from the cache by the CPU, and it increases. So obviously whenever the access time is less, the speed of your CPU increases, the execution time of your program or your CPU work also increases. It can perform more work in a less amount of time, and it enhances the performance of your CPU. And moreover, it is used to store only the most frequently used data. These are all the advantages. Coming to the disadvantages of cache memory, as we know, the capacity in terms of a storage capacity is very less compared to your main memory, and cost of implementing this cache memory is very high. It is higher in cost compared to your main memory, and the management of your cache memory is very complex. So it is complexity in management, and there is a possibility of data consistencies may arise. Sometime, as we know, whatever data is present in the cache memory, a duplicate copy will always be available in your main memory. So when you are performing a read operation, there will not be any consistency in your data because both the copies have the same data. But whenever you are performing a write operation in the cache memory, you have to make sure that the same updated copy of your write operation is also available in your main memory. So there is a possibility or a potential for data inconsistency, especially in terms of a write operation, and increased power consumption. It consumes more amount of power compared to your main memory. So these are all the advantages and disadvantages of your cache memory. Thank you.